Hello, everyone. My name is Kareem Villaseñor, and today I'm going to be talking about gradient descent. But before we get into gradient descent, we're going to have a little recap of the neural network structure that we talked about in the last video. Okay, so neural networks learn in a very interesting manner. So, for the sake of this example, we're going to use the one from last video. So, imagine we want to recognize handwritten numbers. So, we would take a picture of a number, and this picture is made up of pixels. Each of these little pixels is going to represent a piece of information, depending on how light or how dark it is. So, this image is sent through a neural network where it passes through several different layers of neurons. And each of these neurons takes information from the previous layer and it does some calculations and then it passes it to the next one. And in the end of this, the output layer tells us which digit the network thinks that the image represents. So in this case, it would go through the first layer and then at the end, the output would display a 9. The more layers and more neurons that the network has, the better it can learn to recognize patterns like lines or curves or edges, and it'll make a better choice on which number it thinks it is. Okay, so now let's talk about how the network actually learns to recognize these numbers. When we first train the network, it doesn't know what it's doing. It starts off with random guesses. So if you show it a picture of a 3, it might guess a random number like 8 or 7 or 2. Like it's going to be completely wrong. It's not going to have a good guess. But once we start giving the network uh, examples with the correct answer linked to each of these examples, these examples are called training data. The network is going to start adjusting its weights and biases to get a better understanding of which number is which with all the examples that we give it. And so it does something called supervised learning where we will give it the examples, and if it comes out as correct, we mark it correct. If it's not, we mark it incorrect. And then it starts to slowly develop learning which numbers are which. At the end of the day, the goal that we're trying to reach is making for the network to learn from the examples it's used before and make good guesses even when it sees new images that it has not seen before, and it can correctly predict what number it is. Okay, so to help the network learn, we need a way to measure how well it's doing. So this is where the cost function comes in. Think of the cost function like a kind of a scoreboard. It'll tell the network whether it does a good job or it needs to try again. So let's take our initial example here in this picture. Let's say the machine guessed an 8 instead of the number 3. Then the cost function will give it a higher score, a higher score being bad. And then it would try to guess again. And if this time it gets the number 3, then it's going to give it a lower score. Essentially, a lower score is better and a higher score is worse. So this right here is the cost function, which takes the weights of the numbers, and that determines whether the system is doing well or if it's not doing well. So once we have the cost function, the network's goal is to reduce the score over time. This is done by using a method called a gradient descent. And so we can use this image right here to visualize what we're doing. The little yellow circle is a ball rolling down a hill, and the cost function is the hill itself. So in this sense, it would be the red line. And so if the ball starts at the top of the hill, it's gonna roll towards the bottom. And so we need to figure out which direction to go so that it can go to the lowest point in the image. So in this case, using the cost function would allow us to determine that going right would lead to a lower point. The network is kind of similar to this ball and hill example, as it will adjust its settings a little bit, and if it sees that it's going closer to the minimum, then it will keep going in that direction. But if it sees that it's getting farther away from the minimum, then it will not go in that direction and instead go in a different direction. Okay, now let's talk about the gradient and its role in all of this. So this is the gradient is essentially the direction that the network follows so that it can improve. Instead of just looking at one number, the network has many settings, quote unquote, weights and biases, and each of these weights and biases affect its final prediction. The gradient helps the network figure out how to adjust all of these in the right direction in order to lower the cost. Because if you recall what we said in the earlier slide, we said that the lower the cost, the better. And the higher the cost is worse. And so what we can do is we can think of the gradient kind of like a map, and it'll tell the network the best way to change so that it can improve its prediction. So when the network calculates the gradient, it knows exactly what changes to make so that it can get closer and closer to the correct answer. And it's going to keep repeating this process over and over until it becomes really good at recognizing the digits. And that way, it'll slowly start to continue to improve with more and more data. And just to wrap up a little bit about what we talked today, so neural networks learn by looking at a lot of examples and adjusting their weights and biases to get better at making the predictions. They utilize something called a cost function, which is used to measure how right or how wrong a response is. So in this case, being wrong would yield a higher cost, and being right would yield a lower cost. In the next lesson, we're going to talk about how the network calculates its gradient, and that is a term called propa- it's called back propagation. That's the sorry about that's the act of the network calculating its gradient and updating its biases and weights. Thank you for watching. If you guys want to see more content related to I will continue to be making videos and be updated every week. Thank you.